Most people live in houses, they have addresses. They may live in castles, they may live in caves, they may live in tents. But although they were born there, their DNA came from elsewhere. Their DNA was forged through processes of migrations and slavery and victories and conquests. But it was not necessarily formed where they currently live. And the question where we came from is one of the most basic questions the human species has always been asking: where am I from? And to answer this question, we developed this tool that we call the GPS, because just like the satellite navigation system, this GPS looks at your DNA and triangulates your coordinates, your geographical coordinates, to find out where your DNA was forged, which gene pools came together and made you into being that later on may have moved to the UK or England, but this is not really your home. We decided to develop these tools because previous tools had very limited accuracy of about 700 kilometers in Europe, and Europe alone, but nowhere else in this world. And we figure out that this is because of limitations of these models and because they do not understand these processes that humans have been going through. Rather than trying to think which original populations gave birth to us all, we envision the world as composed of gene pools, regional gene pools everywhere else, and realizing that these gene pools have been mixed throughout history, we try to match your signature to the signature of these mixed gene pools to try to find out the origin of your DNA. We do these things amazingly accurately. We can place 83% of the populations in the world back to their country of origin, and the remaining from the country where they migrated from. We show that we can predict people back to their village of origin in the case of Sardinians. So if somebody gets lost and he gives us their DNA, we can place them in their village of origin or close enough for them to find their way home. Our technique differs from alternative techniques in that it models human populations, all human populations, as mixtures. We do not consider races. We do not consider populations emerging from one another. The way it works is that we looked at populations in different parts of the world, and we looked at the DNA that is typical only to these particular regions. And we had, for example, sub-Saharan Africa and North Europe. And then we looked at populations that reside in these regions, and we tried to model them as a composition of these different gene pools. And once we had those signatures of populations that are known to have resided in these geographic regions for a very long time, then we were able to take a test user, look at his signature, and try to fit it geographically close as we can find to these populations. And this is how we achieve our greatest accuracy. The Y and mitochondrial DNA are uniparentally inherited. That means that you get your Y from your father, who got it from his father, and the mitochondrial from your mother, who got it from her mother. In every generation, we're losing some of your parents' and grandparents' data because it is not inherited down the line. Now, both Y and mitochondrial DNA have very limited geographical resolution up to the past 15 or 20,000 years. After that time, they mix too much because of these population movements, and just looking at a haplogroup does not necessarily tell us where you originated. By contrast, your autosomal DNA is inherited directly from your parent, so that 50% come from your father and 50% from your mother. So if your father is Japanese and your mother is British, your DNA would show equal signature of British and Japan, allowing us to report your biogeographical origin very accurately. A lot of people today have a good sense of where they came from, but they continue looking for more accurate answers and validation through their DNA. Let's think of the Vikings, for example. The Vikings are northern German populations who moved to Scandinavia. When they moved to Scandinavia, they mixed with the local populations, and the longer time they mixed and the more open-minded they were, shall we say, the less Germanic DNA was maintained in their DNA. When these Vikings moved to the UK, the same process took place. Some people believe they're descendants of these Vikings. If this is correct, the GPS will tell them that. GPS can be used to study modern populations that are on the verge of extinct or are detached from their ancestry due to history of prosecution and migration. One such examples are the Siberian Cats people, who are numbered today less than 150 people. These people are considered isolated population. Their language is unclassified, so we do not know where they came from. But now we can find out using GPS. This application has tremendous potential for forensics. It can help adoptees find their home. It can help missing children be returned to their country of origin. It can help fight human trafficking. We hope all these applications will be very useful to the law enforcement one day. If you would like to find your roots using the GPS tool, what you need to do is order a DNA kit from one of the multiple companies in the field that would genotype your autosomal DNA. You will get back from these companies a file with your genotype, which you will later upload to our website, and where you can run the GPS algorithm. The GPS would analyze your DNA, build your DNA signature, and find your geographical homeland and give you back the result.